Okay, here we are. Last section. I'm going to redo problem number 7 because my eyesight is going and I didn't read that number correctly. It is in fact only 8 years later, that you're evaluating the worth of the car, the value of the car. Anyway, the correct answer, if you're doing it on the annual basis, that equation would be 15,048. The continuous value is going to be somewhat higher. $500 out of 15,000 is not a lot. Same is true with the change in years. It takes 19.7 years using this equation, or 20.6 years. I'll really take either one of these. I don't specify. If I do specify, you're going to want to use continuous if I say so. If I don't, it's dealer's choice. All right. To number 8. All right. We are talking about $2 million invested. You can use 2 with all the zeros, or you can just understand that your answer is going to be in millions. You'll get 5.187 million or 5,870,000. So I think these are fairly clear. I'm not going to go into those in great detail. Just be super careful when you type into your calculator. Practice doing this so you can get those same answers. All right. Those 3 formulas will be on the back. You just need to be aware that this is annual, this is compounding, and this is continuous. That word continuous means you're using e to the RT formula. All right. So now we're using sigma notation here, so understand what that means. When you see a multiplier raised to the n-1, that tells you it's geometric, so you want to go with the correct formula. It's the first term minus the last term times our multiplier, and then 1 minus r, which is that 1.2. This only works if it's finite, and this stops at 50. All right. If it's infinite, that drops away, but that multiplier must be a decimal less than 1, or the absolute value must be less than 1. Anyway, that's the total right there. For this problem, you're adding up the first 1,000 terms of an arithmetic. Again, you need the first term, the last term, and then that tells you how many pairs you've got adding your first and last term. So that's that answer right there. Now we're on to triangles. So solving triangles, I will definitely give you more room on the exam. I'm sorry. It's really squeezed in here. This first one is 3 sides. Side, side, side is going to give you only one triangle. Sometimes it can give you none if these 2 arms aren't enough to span across that, but you can draw a little picture. The 2 shorter sides must add up to be equal or greater than the third side. So anytime it's side, 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 or side, angle, side, you use law of cosines. Law of cosines right there. That's 10 squared is your opposite side of whatever angle you're going to solve. You could choose to do any one. I like to start with the bigger side because then the ones that you have that remain are less than 90 degrees, and that's easily done in law of sines. 10 squared equals 9 squared plus 7 squared, then minus 2 times 7 times 9 cosine of the angle. We work backwards to find the angle. I get the angle as 76.2 degrees. Once you have one angle, you can then use the law of sines to find the second angle. Once you find the second angle, you can subtract from 180 to find the third angle. 3 sides, 3 angles, all done. B is the dreaded mind the gap type problem. It gives you a gap that is about 15.3. Well, 17 is enough to span the gap, but it's less than 20, so it'll swing through and hit twice. So I've solved for one triangle here. Here are the 2 missing angles and the 1 missing side. When you start with the larger, on the outside and you swing it in, that first angle you're going to find will be less than 90. It will always be less than 90. And then to find the second triangle, if you would need to do that, you can see how here's that outer angle I found. Well, it's going to be an isosceles triangle. These 2 sides, when it swings from the outside in, this angle will be the same as that one you found before, but now we're going to be looking for this angle for our triangle, so I subtract that from 180, and that's going to be the obtuse angle, more than 90 degrees, is 115. I add that to 50 and subtract from 180, and I get the other little sliver of an angle, 14 degrees, and then I just set up a law of sines to find the missing side. So this is the second triangle, number 2. All right. Then this last one in C, everything's the same. 20 and 17 are the same. That's actually a 17, that's correct. That is not an oops. I thought it was a typo. I started to correct it, but it's not. But this is what changes. Now it's the included angle. So this is side angle side. Side angle side is law of cosines. So I work through the law of cosines. I find the missing side is 15, and then I solve the missing angles by law of sine. I got so into it I did the law of sines for the third one, but of course you can just add those two angles up and subtract from 180, and it's much easier. Alright, so this quad reg and linear reg problem is pretty straightforward. Put this data in L1, put this data in L2. You get these points. They look somewhat linear, but they're slightly curving. If you do the quad reg, it bends down like this. There's a maximum that's right there. A linear one will have no maximum. Just be able to find those and plot those. I would not just automatically draw the sketch based on your window. I would go through and look for the maximum so you can fit it all in. Otherwise, your screen will be really small and you'll be left going off the page, because the interesting stuff happens when you project into the future. Alright, so you might want to do a rough draft and then sketch it finally later. The linear reg equation is right there. The quadratic regression equation is right there. You don't have to go to that many decimal places, but I did for fun. And then this is where it gets more interesting. What would you argue is the best amount of money to put into research to maximize the profit for the company? Well, in the real world, there usually are limits to how much you can grow. You can't just keep throwing money at something and expect always for it to get better and better and better. So I would tend more towards the quad reg. The maximum is found based on this data to be at 24.9 or $24,900. So that's the best amount to invest to make a maximum profit of over $80,000. But if you believe, like some companies sometimes believe, you can just keep pumping more money and you'll keep getting bigger and bigger and bigger till you take over the planet, well then you can answer that way. But I think this is probably more realistic. I'll put the star by that one. And in the end, here we are just graphing this. This is just a pretty straightforward polynomial. Nothing too fancy. I did expand this all out. I'm not sure you would really need to do that. I just showed you in case you did do that, that you get this polynomial that's a degree of 3. You want to say that because that is an important aspect. A relevant part of this is the degree. That tells you that it could cross potentially 3 times. It does in fact only cross once. The lead coefficient is a positive one. That tells you it goes up on the right and down on the left because it's an odd number. The even numbers, the arms both bend in the same direction. It has no asymptotes. It has a 0 at -7. That's the y-intercept. It has, that's the y-intercept. This is the 0. It's 1. That's the x-intercept. That's something to label. Maybe I'd put that. Intercepts will be in the word bank up there as well. This one is more interesting, probably worth more points. It's a rational function. We did quite a bit of work on these. You really want to look for vertical asymptotes when you get division by 0. And you want to factor that and set each of those factors equal to 0. So x cannot be 5 or -2. That tells you that the vertical asymptotes are at +5 and -2, so sketch those in and label them as I did. You might want to shift the scale down because these are kind of going off the page. This will inform you about the domain. The domain is all real numbers, but x's cannot be 5 or -2. Then the horizontal asymptote comes from the battle of the degrees of the numerator and the denominator. Here they happen to be equal. So it's the lead coefficient for each of those. 5/1 is 5. If this was a 3 up there, that would win and it would go to infinity and have no horizontal asymptote. If that was a 3 down there, the denominator would win and it would go towards 0, and these lines would come down and hug 0. Alright? But if I'd had a 1, if I had the 1 up here and the 5 down there, then these would come down and hug 1/5. So you want to know the math that will tell you the difference between 1/5 and maybe 0. Alright? The range is, we talked about the domain already, the range then will be all numbers above this boundary 5 and below or including this boundary at the origin. Alright? That is about 95% of what's on the test. Don't be surprised if you don't get a little bit of an extra challenge problem here or there. Good luck.